Right. So I'm really excited to share with you all that we're going to be hosting a speaker series each month from now on until the month of May. I'm really looking forward to the next speaker series as well. We'll be welcoming a gentleman that some of you know. His name is Bobby Ives, and he'll be speaking October 14th, our next speaker. And he's going to be discussing with us the history of Monhegan Island. I'm delighted to share with you all that our speakers are from all over the great state of Maine, and the topics that we're going to be talking about and covering range from science to history to adventures spent at sea and much, much more. So I just want to take a moment before we get started to share with you all some of what's happening here at the boat shop. As you all know and are participating in, we have a new initiative, which is our speaker series. Also, we have our fall apprenticeship fully underway with 8 amazing humans from all over the US. Another thing that we're going to be doing here at the Carpenter's Boat Shop is we're offering classes year round. And some of those classes range from build your own toboggan to our classic of building a Monhegan skiff. And in addition to that, we also are offering classes in regards to coastal navigation. Many, many classes coming your way. I'm also excited to invite you all on October 23rd. We're going to have a cider pressing day hosted by staff, apprentices, as well as our fabulous board from 9 to 12. And we'll be pressing cider, pressing apples for cider, and don't worry, there'll be lots of donuts there. Annie has added a link to the chat room. If you feel compelled to make a donation to the Carpenter's Boat Shop this evening, I want you to know that there's no amount that is too small and that all proceeds support our programming. There is going to be a lucky winner this evening, and we are going to give away a shaker box this evening, handcrafted here at the Carpenter's Boat Shop by one of our many volunteers. So if we don't already have your email, please sign up on our website and mention the speaker series to be entered into the raffle. And we've shared in the chat a link for you all to join. We're going to ask that you all put your questions, if you have any this evening, in the chat room. And Rick is going to do his very best to answer all of those questions at the end of this evening. So I'm really excited to introduce Rick Wahle to all of you as our very first guest speaker. He's not only a professor at the Darling Center, he's also the director of the Lobster Institute. Sorry about that. And this evening, he's going to be sharing with us his insight and vast knowledge in regards to lobsters, climate change, and the effects on the Gulf of Maine. At this point, I'm going to turn it over to Rick. And I can't say thank you enough for all of you for joining us this evening.
All right. Well, thanks an awful lot, Alicia. This is really a pleasure to be able to hang out with you guys. I imagine a lot of you are from the peninsula, so this is a really special community to me. But I want to start out by congratulating Alicia and Annie for becoming members of this community on the peninsula here, and especially Alicia for taking the helm at the boat shop. I really hold the boat shop near and dear. My whole family has been through the boat shop in one manner or another. And of course, aside from the work in the shop, there's always a good hockey game out on the harbor pond in the winter. And I'm looking forward to this winter, as long as it doesn't get too warm. Yeah, and it's great to see some familiar faces here, Bobby and the Fillers and Dave Levesque and others. So this is really a special evening for me too. So I'm going to share my screen here and just give me a thumbs up that you're in fact seeing it. is that good? Okay, good. Well, all right. I think we can get going then here. Okay. Oops. Sorry about that. There we go. Oh. Okay. A few little technical glitches, but I think we're there now. Sorry. Well, I am really happy to be able to share some of the things I know about lobsters and the changes going on in the Gulf of Maine. And I'm looking forward to your questions too at the end. We're, yes, going to be looking a little bit back in the history of lobsters, but also looking ahead and talking about some of the forecasting tools we've been developing here at the university and with collaborators up and down the coast. But I'd really like you to come away with 3 takeaways here from this talk today. And the first is that, you know, many of you may, since you live on the peninsula, or maybe not, know that we're now at historic highs. I mean, absolute booming highs in terms of the lobster fishery here in the Gulf of Maine and really in the United States and Canada. And of course, the big question is, how long will it last? I also want to impress upon you that the ecosystem changes that we're seeing and will be seeing have led to sort of perilous dependency of our coastal communities, our coastal fisheries on this single fishery. And I'll sort of lay out the story of how that came about. And finally, I want to also impress upon you that our ability to predict and adapt to change depends on an ecosystem level understanding, a more holistic level understanding than just, you know, what the fishermen are doing or, you know, what the climate's doing, but you really have to take it all in together. So let's unpack this story. And what I want to do first is give you a little first principles, some ecosystems 101, let's call it. And when we're talking about changes in the ecosystem, we're also often talking about either bottom-up effects or top-down effects. And I'll explain to you what I mean by that. By bottom-up effects, we're talking about the changes that occur as a result of changes that are happening at the bottom of the food web. That is, starting with changes in the nutrients. Then, of course, the nutrients feed the and the sun and carbon dioxide too feed the plant biomass. In the water column, we're talking about phytoplankton as the plant biomass. And that, of course, that productivity percolates its way up the food web and affects it. And in fact, our fishery yields are tightly coupled to that productivity. And in a study that was done by some Canadian colleagues already about 15 years ago, they sort of took an approach of sort of carving up the coast and the shelf waters of the not only the Gulf of Maine, but all the way up to the Labrador coast and the Gulf of St. Lawrence. And they carved it up into little parcels and looked at, from satellite imagery and other sources, the levels of productivity. Where you see the red, dark red areas, those are the areas of highest primary productivity. The areas that are in blue are relatively low productivity. And then they plotted that productivity that's on the y-axis, the x-axis here on the horizontal axis, against the landings, the actual harvests of fishery yields of all types from these areas. And they found a really strong straight line relationship. Some of the lowest areas, like out here on the Grand Banks, are in blue and have low levels of primary productivity, and relatively low levels of landings. But the one at the peak here, number 7, is right in our backyard. That's a parcel, a large part of which is in the Gulf of Maine. And so that's what makes this part of the world such a special part of the world. And of course, the Europeans, the Basque fishermen, the English knew about this already in the late 1500s and were harvesting the cod and haddock from these areas. And of course, Damariscove Island was a cod drying station right off our coast here. A very special part of the world, this Gulf of Maine. Now, so that's what we mean by bottom-up effects. Where you have the highest primary productivity, you tend to also have the highest levels of overall fishery productivity. Makes a lot of sense. But we also talk about, oh, I'm going to admit this guest. I guess I've been given host rights there. Okay, sorry to interrupt there, but I guess I've been given host rights. Okay, so going from bottom-up effects, let's also talk about top-down effects. And this is where we're talking about alterations at the apex of the food web. That means the top predators. When you start messing with them, it has cascading effects down the food web. And of course, the big targets at the top of the food web in terms of fisheries are the big fish, cod, tuna. These are all big fish that are at the top of the food web and control and regulate the populations below them, the forage fish, even crabs and lobsters. And so when we talk about harvesting effects as top-down effects, a professor at University of I'm just forgetting the name of the university he was from, but a fellow by the name of Daniel Pauly, University of British Columbia. Daniel Pauly, already back over 20 years ago, coined the term fishing down the food web. And that refers to harvesting down the big predators, mining them out of the ecosystem. And of course, that completely alters the trophic structure of the food web and releases the populations below them from predation, allows them to explode. And so this is exactly what's happened in the Gulf of Maine over the decades, starting already with harvesting going prior to European colonization, but especially after European colonization, when big trawlers, especially back in the 50s, 60s, 70s, 80s, really started to take their toll. They depleted the large predators, and in turn, that meant a boom for lobsters. And so groundfish, if you look at this at this time series here, I can't think of a better illustration of this top-down effect concept, where the groundfish, which really comprise a whole assemblage of different species. We're not just talking about cod or haddock or monkfish or flounder, but a whole assemblage of over a dozen different species that over the decades have been dramatically depleted to the point where back in the 50s, they comprised, really dominated our fisheries. Now they make only a tiny fraction, less than 1% of our fisheries in the Gulf of Maine. And while lobsters were always a big part of the fisheries, we've always been known for our lobster. It wasn't really until the 1980s when things really started to explode for lobster. And so, we're talking about both bottom-up effects that explains a lot of the geographic difference and even temporal changes in the productivity of the fisheries productivity of our area. But we also have to consider the top-down effects of fishing down the food web. And in fact, it's not just a matter of rapidly declining biomass, collective biomass of all the fish, but the average size of the fish has actually declined because of size selective harvesting. The big ones have always been harvested first. It's sort of a natural consequence of fishing. And so you have the story of the incredible shrinking fish. We just don't have the big fish that we had before. You don't hear about the big, 50-pound cod that we used to see on the coast here, or that John Cabot saw on the coast when he was around the waters of Monhegan. So that's sort of that's our little ecosystem 101. But I also want to impress upon you the really special thermal geography we have in this part of the world. And really the best way to view that is in the context of an entire map of the world. This is a thermal map of sea surface temperatures. And of course, the red and yellow colors are the warm areas, and green and blue colors are the cold areas. And one of the things that really is striking about our part of the coast is how steep the gradient is from cold to warm. And I've got this, I've got our area off New England blown up here, zoomed in. And you can really get a better sense of the geography of that thermal gradient. And this is a summer satellite image, a composite over multiple years. So it's an average thermal map. And you can see how dramatically things change along the coast of Maine, so that, and especially across between the mid-coast here and into down east, right at the barrier being right at Penobscot Bay. This is just a really dramatic gradient here, so that we're in midsummer temperatures, we're seeing on the order of in Fahrenheit 60 degrees midsummer at the surface here, whereas down east you're lucky if you get much higher than 50 degrees, and so that's in part what explains the dense fogs we see during the summer down east. And so this has important consequences for the distribution and abundance of species. And just to create a more dynamic view here, I'm going to just give you a better picture of what's influencing this gradient. It really has a lot to do with the confluence of the Gulf Stream, which is this swirly mass of water here going all the way up from the Gulf of Mexico up to the British Isles. But you also get, as we zoom up the coast here, we see this cold current coming down from the north. This is the Labrador current, and it wraps around and it gets entrained in a coastal current that gets drawn down into the Gulf of Maine. And this is those two currents are sort of battling it out off our coast here. The amazing thing, the unique thing about the coast here is that this cold water, as cold as it is, it's really nutrient rich, and it flows into the Gulf of Maine, comes down to a pretty low mid-latitude here for polar waters, and it mixes with these warm waters, and these warm Gulf Stream waters are not nutrient rich. They're actually pretty nutrient poor, but the combination of the warm with the nutrients at a lower mid-latitude is what plays a large role in the productivity of our system. And this is what's changing, the balance of this confluence. And I'm going to come back to that at the end. So let me just exit this and come back to my slides here and move on. Now, of course, with a warming climate, we've been seeing warming temperatures. In the Gulf of Maine, since 1982, we've seen an average increase, and this only goes to 2015, so it's changed a little bit, but on the average, overall, about a 1 degree Celsius change, warming increase per 40 years, every 40 years. But since about 2004, that's been accelerating and accelerating by a factor of 10. So now we're seeing on the order of a 1 degree C change every 4 years. And now we can extract, we've got a few more years on here since this publication came out in 2015. But, all the reports are that this accelerated pace is continuing. So accelerating warming, and our part of the globe, our coastal waters are warming faster than about 99% of the world ocean. So we're really at the cusp of this warming trend and a leader. We're seeing the things happening faster than they are anywhere else. So, and this is important for the reason that many organisms have, really all organisms have thermal thresholds, important minimum and maxima above which and below which they thrive and do not do well outside of. For lobster, we're talking a maximum at about 20 degrees Celsius. So that's at about 68 degrees Fahrenheit. Their low temperature, at least for the early stages, the larval stages, is at about 12 degrees Celsius. So that's at about 53 degrees Fahrenheit. And this zone, we'll call it the lobster comfort zone, if you will, has been shifting northward over time. And what that's meant for the distribution of lobsters is that since the 1960s, we've seen a northward shift in their distribution, so that by the mid-late teens, 20-teens, the highest concentrations of lobsters were off our coast and off Southwest Nova Scotia. Now, this is interpolated data from NOAA's trawl survey. It's really a groundfish trawl survey, but it provides some really important information on the distribution abundance of lobsters and crabs and other invertebrates as well. So it's more than just a groundfish trawl survey, but it illustrates really well the consequences of the warming environment for lobster. Now, of course, in southern New England, things have been getting bad for lobsters. We've seen mass mortalities as a result of shell disease. They're essentially near collapse. But the warming has been good news for lobsters in the Gulf of Maine, especially the the eastern Gulf of Maine. And that's what I want to unpack for you a little more here, because we may only see illustrated a time series of the entire state's landings, but really you've got to split it in half by northwest and southeast sectors of the state. Now, this graph really illustrates well the multi-fold increase in landings we've been seeing. It's about a 6-fold increase in landings we've been seeing since the mid 1980s. And actually, I started studying lobsters around 1985, so I'd sort of like to take credit for this, but I don't know whether that would pass the straight face test. But in any case, we've really got to divide the coast in half and see where this trend has been happening. And so I'm going to illustrate it in a slightly different way. So we standardize for the lengths of coastline or areas within each part of the state. And what we've seen here is this dramatic explosion in the northeast part of the state. Now, when I started in this game, down east was really pretty impoverished in terms of lobster production. And that has entirely changed. When I started in this in the late 80s, 90s, really the southwestern part of the Gulf of Maine was the big lobster producer on a per kilograms per kilometer basis. Southwest Gulf of Maine had it hands down. But a tipping point happened. The shift really happened about around 2008, where all of a sudden the northeast sector really started to take off. It had been on an upward trend for a while, but then really took off during the 2010s, just before the 2010s and onward. And so this is the part of the coast that's really explained this dramatic increase and has elevated the fishery to its current status now as the most valuable single fishery in the United States. And since the same thing has been going on in Canada, it's the most valuable single fishery in Canada as well. So you really make the case that this is the most valuable single species fishery in North America. Now, about 90% of the US share of the production comes just from the Gulf of Maine, and about 80% of that comes from the state of Maine alone. And not surprisingly, it's also Maine's chief export commodity. So it's no surprise that our coastal communities here are highly dependent on this fishery, and why it has such a high profile on a national scale. And so there's been a lot of research underway to try to develop forecasting tools for trends in the fishery to see where are we going from here. And they're both on long and short time scales. One of the shorter time scales forecasting tools that we're developing is based on the settlement of baby lobsters that fall out of the plankton just after they complete their larval stage, and are a little. This little guy is just past the settlement stage, maybe 1 or 2 molts. But the question is, can we use these little guys as an early warning system for trends in the fishery, say 6-7 years later, when they would grow up to enter the fishery? So we've spent a lot of time developing a methodology to sample these young of year, as we call them, the new babies of the year, using diver-based methods and vessel-deployed methods. So this diver-based method, I'll just explain this to you a little bit, is a method I developed back when I was working on my PhD 30 years ago. And it's basically an underwater vacuum cleaner. That's what this tube is. It gets a supply of air into the tube. The air rises and creates a vacuum. And then you can, the couple of divers can vacuum fixed areas of the seabed, turning over the rocks and sucking up the little lobsters and other critters, crabs, and so forth out of their hiding places. And then we can switch out, they're captured in a mesh bag at the top, and then we can switch out the bag for a new frame on the bottom. So we do multiple frames. These frames are called quadrats. And then we get, then we can go to multiple locations along the coast. I'll show you a map in a minute to show you our spread along the coast. But the other methodology is this passive post-larval collector, as we call it. These are vessel deployed. They lend themselves really well to working off lobster boats because these guys are well equipped to use them or to deploy and retrieve them. But they're basically, this is Flintstone technology. This is just the, rocks, which creates great habitat for little lobsters. They're just habitat units with a fine mesh on the bottom, and then put in what's basically a lobster trap design, but without an entrance other than the little holes in the mesh that the baby lobsters can settle through. And so, so we use these two methodologies. And while we started doing this work off the mid-coast of Maine 30 years ago, pretty quickly it spread up and down the coastline. So now we've developed this collaborative of state agencies like Maine Department of Marine Resources and their counterparts up and down the coast. The red dots are where we're doing the diver-based suction sampling, and the yellow is where we're doing the collector deployments. And so this is the list of collaborators up and down the coast, from Memorial University in Newfoundland down to Rhode Island Department of Fisheries and Wildlife, and a number of locations in between. But I need to give a shout out to the fishing industry here, because a Ready Seafood Company out of Portland, one of our biggest lobster dealers in the state, stepped up to the plate and said, we want to be part of this, and we want to invest in it, and we want to deploy collectors in places where you guys can't go as divers. And so we have a series of collector deployments over a range of depths, these circles here within the squares. And they've now been doing that for the past 5 years, and have even recruited other food companies like Red Lobster and Santa Monica Seafood into contributing to this. So the industry's really stepped up to the plate. They see it as valuable sustainability research that they can contribute to, and they do. Now, but here's some of the data that are generated from this. And before your eyes go cross-eyed looking at this, I'm going to just walk you through and have you look at some of the peaks and valleys without getting into too much detail here. But again, here's the map distribution of the sampling, and here's the yellow again is the collector samples, and the red is where the diver-based is being done. And we've got the north end here in Newfoundland and the southern end here in Rhode Island. And I just highlighted this box on the Rhode Island time series just to indicate how things have really collapsed there as a consequence of mainly shell disease and overheating. But you know, in about the mid 2000s, we saw this dramatic boom I already talked about in down east, and this is where it happened, right in that time frame. But then since then, we've seen a downturn, and that's gone Gulf wide, right through the Gulf of Maine, and this has really got folks scratching their heads because everybody would have thought that, you know, you would have anticipated that at a time when we've got a boom in lobster production here, we've got more adult lobsters out there than we've ever seen, more egg production, we would have expected the larval settlement to be going through the roof. But just the opposite has happened, except in the Gulf of St. Lawrence and Prince Edward Island. Most recently, we've seen a big boom. But this decline that we've been seeing about over the past decade now in the Gulf of Maine has everybody scratching their head. And we're calling it the great disconnect in the Gulf of Maine, where we have all-time lows in settlement at a time when we've got peak egg production. So what's going on? Well, this story was published by me and colleagues in the Bulletin of Marine Science in 2018, and it's a subject of intense research right now. But rather than show you a lot of charts and graphs, I'm going to illustrate sort of the crux of the story with some graphics here. And so let me just walk you through it. So again, we're at a time of all-time high of egg production. Here's an egg-bearing female. Numbers are really high. We know that because of these trawl surveys they do out on the NOAA ships offshore, and even from our state trawl surveys. But at the same time, our American Lobster Settlement Index diver surveys are showing that the young of year that settle to the seabed that come for these eggs are at an all-time low. So what's going on? Well, this is where we're talking about the great disconnect. And our hypothesis is that larval survival is limited by the planktonic food supply. And so the work we've been doing over the past years since 2018 has focused on this question. And we're sort of just in the process of testing it. Now, let me just fill in some of the gaps here with what else we know here. So one of the things we're seeing is we can go beyond the egger stage and the young of year by filling in the gaps of the stages in between by virtue of a monitoring program that's unique to the coast of New Hampshire. It's conducted by a consulting firm called Normando Associates right off the coast of Seabrook as part of the monitoring for the Seabrook power station. But they have the longest time series running on larval abundance. And so they've been seeing that the earliest stage larvae, which are depicted here, their abundance has been scaling right up with alongside the egger abundance, as you'd expect. The more eggers you have, the more stage 1 larvae you'd expect to see, and that's exactly what they see. The thing is that they also see in that same monitoring program that the post-larval numbers are way down, and in fact, they correlate really well with the young of year numbers that we find on the seabed. So now we're connecting post-larvae in the water column to young of year on the seabed, both of which have been in decline. So here's where the disconnect is happening. Somewhere between the early stage larva and the late stage larva. And we think it has to do with the food supply. And one of the food supplies that really correlates well with the post-larval numbers is Callanis Finmarchicus. Now, Callanis Finmarchicus is a little tiny crustacean, smaller than the lobster larva, but it's really the foundation of the food web for many other species. Everything from right whales to herring love Callanis Finmarchicus. The reason they love it is because they're like little butter balls. They're full of fat. About 60% of their body weight is oils, lipids that energize the food web. And so our hypothesis is that this Callanis is a limiting factor, a limiting food for these post larvae. And so, so we're in the process of testing that question. One of the things we asked at the very beginning is whether these larvae can actually handle Callanis Finmarchicus. And so here's a little video of a larva. The larva is here on the head of a pin. We use this little super glue technique, and super glue is amazing. You could just put a little tiny dab of it on the back of a larval lobster, which is about the size of a peppercorn, and fasten it to the end of a little pin, and then video at high magnification, and then introduce the copepods. Now here's Callanis Finmarchicus. You can see it's got this sort of oval body and these big long antennae that it uses to swim and detect its environment. And lo and behold, what happened early on in the video here is here's the larva waiting for something to come, and then boom, there's a little Callanis that just happened to encounter it, and it snagged it. So, and in fact, we've done some subsequent experiments, and we know that these guys not only can handle them, but they prefer them over other copepod species. So this is just one result of a battery of different experiments and surveys that we're doing to get a better handle on this hypothesis. And there are certainly other alternative hypotheses we can't necessarily rule out. Could be that there's some other mechanism controlling them both the larvae and Callanis Finmarchicus, things like another predator, or maybe it's just currents carrying them both out or in at different times of the year or over the decades. And so while we're not ruling out those other hypotheses, this one is gathering momentum, and stay tuned for more. But the last thing I want to bring us to is the forecasting tool that we've developed, and so I'm going to walk you through how we do this. And really, you can think about this as an approach where, much like you know, if you use your weather app on your phone, and you look at your weather app and say, okay, well, today it's 60 degrees in Round Pond, but they're saying all the way up to next Thursday it's going to be 64 degrees, and so that's a modeled prediction, right? That's a model that's predicting that number, and the way to assess the skill of that model is to wait until next Thursday and see how correct that prediction was 7 days out, right? That's exactly what we're doing here with our predictive model using the early warning system with lobsters. Here's where we have the settlement index from one of our areas, where you can see there's a low period and then a boom and then a decline. And we actually run those numbers through sort of a mechanistic, through our mechanistic understanding of what happens as they grow and mature and die through natural causes before they enter the harvest. And so we have equations that explain growth and mortality. And so this time series is translated into this time series of projected landings. And it's smoothed in part because some grow faster, some grow slower. And so the bumps and pitches and yaws get smoothed out. But I'm gonna just back up here. When we generate this projection, this prediction in, say, 2013, this is the 2013 model, we asked how accurate was our forecast out 6 years? How accurate was our 6-year prediction given what we knew in 2013? Well, in 2013, we could only compare our prediction to the landings that we had available in 2013, and we fitted this model with compared this model output against the observed landings, and we saw a pretty good fit there. The landings are the observed landings are the black line here, and the modeled landings are the red line with the blue envelope. Now, then we had to wait the subsequent years to see how good that 2013 model was at predicting the subsequent trends. As it turned out, this was a pretty good model. And so we used the same approach. Oh, and of course, this hit the headlines, but then we used the same approach in other parts of the coast of Maine in the different lobster zones. And we saw, well, our 2013 model was pretty good at predicting out to 2019. Well, now we have an updated model, and in 2019, and we're projecting out another 6 years, so to 2025. And of course, our skill assessment is 1 year in at this point. And so far, we're seeing we're doing again a pretty good job. And this was sort of surprising in that despite the impacts of the pandemic on the fishery, they had a slow start back in the spring of 2020. They made up for it in spades later on. So they actually harvested about what we predicted them to harvest. So the takeaway was that despite the pandemic, landings aligned pretty well with the predictions that we had. So that's the short-term forecast, just taking lobsters from settlement, the 6-7 years out to when they mature to the fishery. But what about the multi-decadal forecast? This is a more sophisticated kind of modeling where you have to consider multi-generational effects, how temperature affects reproductive rates, growth rates, and so forth, and how they can feed back on each other. So, and the temperature regimes we used were the two extremes that the IPCC uses. The ones where under the most extreme curtailed emissions already back in the last decade. And if we were effective, we would have only seen a temperature change following this blue line. If we did nothing, we would see a business as usual trajectory, just taking off, so that by the end of the century, we'd see on the average about a 4-degree increase in temperature in Celsius. So we took sort of the happy, if you can call it happy, medium midline here of a 1.5 degree Celsius increase, and ran that scenario in comparison to what our current observation is for today's production. So here's the blue, intense blue areas here are the areas today where we see the strongest lobster production and recruitment. But by 2050, it's projected that on the basis of this model, with a 1.5 degree increase, that the best lobster habitat won't be totally removed from the Gulf of Maine, but will still be retained in the eastern part in the Bay of Fundy. But we may see some problems in the southern part of the Gulf of Maine and Cape Cod Bay. So, and one of the big takeaways from this this paper that I didn't want to go into too much detail on was that by virtue of the fact that Maine had so many protective measures on egg-bearing females, we were able to capitalize on this these improving conditions. Whereas in southern New England, as conditions warmed and only got worse for lobsters, they didn't have those conservation measures in place and only hastened their demise. So finally, and I realize I'm going a little long here, but I want to come back to the changes in the Gulf, the circulation patterns in the Gulf and off the Scotian Shelf and George's Bank here, because what we've been seeing since about 2008, 2010 is a dramatic change in the influence of the Labrador Current. Before 2008, the Labrador Current, with its cold, nutrient-rich waters, had a strong influence on the Gulf. Since then, the Gulf Stream's influence has become stronger, in part because of actually the relaxed overall circulation in the North Atlantic. The meanders of the Gulf Stream have become wider and more intrusive into the Gulf, and they've eclipsed the Labrador Current, essentially pushing them out of the way. So so it set up conditions for poor primary productivity, poor copepod productivity, and in turn, we think a decline in larval survival. So let me just recap here. So starting with the bottom-up and top-down effects, we know the drivers of food web change are both from these bottom-up and top-down effects. And our coast, as you can see, is a really dynamic ecosystem, and it's been altered by humans at different spatial and time scales. But I can't emphasize enough that we have this resulting dependency on this single fishery right now on our coast that makes our coastal communities vulnerable. Now, as far as the forecasting goes, you know, we're still sort of in the early young stages of developing these forecasting tools, but the advantage, and, you know, a lot of people poo-hoo the forecasts, and, you know, forecasts are always just abstractions of the real world. But what they do is give us a lead time to make choices. They let us create what-if scenarios that inform our choices. And so our ability to predict and adapt to these changes really requires a combination of improving these models, on the basis of our understanding of how the ecosystem works. So with that, I want to bring it to a close and just say a big thanks to all of you for being here tonight. It's really been a pleasure, and I'm happy to take questions to the extent we have time. I know we ran a little long here, but I'm going nowhere else tonight, so we can stay as long as Alicia wants to.
Maybe have him stop sharing the screen. Excellent. Rick, thank you. I do have a question from the community for you.
Okay.
I have a question from somebody that is on Bailey Island, and they're concerned about the impact of the right whale regulations on the fishery. We support both sides of the issue and wonder how this can be resolved. What are your thoughts on this, Rick?
Boy, you're aligning with my own thinking. You know, I think we're all in this boat together. We have really both the northern right whale and our lobster fishery are national treasures, and we need to work together with Canada and the shipping industry to adopt some measures that don't only target the lobster fishery. And that's what concerns me, is that the recent regulations that require a 98% reduction in the risk of right whale mortality over a 10-year period. That burden is being entirely placed on the lobster fishery, or the fixed gear fishery that includes crab pots and gill nets as well. But we know that most of that actually since 2004, no mortalities of right whales can be attributed to Maine specific lobster gear, but there are dozens that can be attributed to Canadian gear and to ship strikes. So it's not a simple story. Maine Department of Marine Resources came out in February remarking on the uncertainty around the proof of responsibility on the part of the lobster fishery. And so while the Lobster Institute is not an advocacy organization, we're looking at the evidence here, and there's a lot to attribute some of the declines in right whale health and mortality to these very changes in the ecosystem that I was just talking about, the declining productivity of this specific copepod, Callanis Finmarchicus, its primary food. So yeah, it's a complex issue, and I think there's blame and accountability, and the solutions to the problem need to be addressed by all of us, and not just by the lobster fishery.
Thank you, Rick. You ready for a few more?
Sure, go for it.
All right.
Yeah, I'm going to depend on you to read them because it's hard for me to see.
Yeah, perfect.
Where to go in the chat. Take them away.
So here's one that's asking about folks here in Bristol, and should we be considering our education system and the training of our young people in considering finding non-lobster related careers?
Yeah, well, I think my response to that is that, having a diverse portfolio is always a good policy. I talked about the perilous dependency we have on this single fishery. And so it's still a very profitable fishery, but there are alternatives out there, like if you want to stay with the working waterfront, and fisheries. There are other fisheries that are likely to emerge with a warming climate, things like black sea bass. There's aquaculture has tons of potential here in the state of Maine. Resolving some of these technological issues, like developing ropeless traps. Right now, ropeless traps just do not pass the straight face test, either with the fishing industry or DMR enforcement. It's just not it's just not feasible yet. And the expense of adopting ropeless is just prohibitive for most normal fishermen. So certainly having alternative means, to find an income, I think is advisable. But I think we still have a strong basis for a fishing-based and a lobster-based economy.
Awesome. Can you talk a little bit, Rick, about some of the alternative theories of the lobster decline?
Yeah. So I talked about some of the. I talked about the food limitation hypothesis. The declines in the copepod Callanis Finmarchicus. That's just one hypothesis out there. Another relates to some of the other predators of the plankton. So it may not be so much about the foods that the larvae are eating as it is about the things that eat the larvae. And we don't have a really strong understanding of that. It could be small fish larvae. It could be gelatinous plankton like jellyfish. We don't have as good quantitative data on them and to look at those correlations. It could be just the circulation patterns have changed and are carrying both the lobster larvae and the plankton out of the system. So those hypotheses need to be tested more rigorously. So far, shell disease, at least in the Gulf of Maine, doesn't seem like it's been too much of a mortality factor. That seems to still be restricted mainly to southern New England.
So I have one more for you, Rick.
Okay.
What effect will the proposed wind turbines on the have on the ecosystem and the lobster industry?
Yeah, that's a good question. You guys are throwing some hardballs at me here, man. Yeah, this is something we're keeping a really close eye on, and we're actually working with the Aquaventus group out on Monhegan, who have that single turbine out there, or are going to be putting that single turbine out there, I think by 2023. But we're developing experiments, sort of a before-after control impact experiment to at least look at the impact of having a turbine anchored to the bottom. These are floating turbines. How that'll affect the catch, the commercial catch in an area. And we're using mark recapture approaches and fixed trap arrays around the turbine. So the jury's still out as to how it's going to be impacting the lobster population or the catches.
Okay, this is going to be your last question, Rick.
All righty.
you talk to me a little bit about what the biggest challenge is in your work in your current work?
Keeping up with it all, I think is the biggest challenge. You know, in the past few years, it just seems like it's been snowballing. All these issues have been just coming to a head, whether it's, you know, COVID or the right whale issue or the wind energy issue or the climate change issues. Bait has become a problem for the area. The quota for bait for herring has dropped by 80%. And just keeping it up with it all is just really a challenge with just you know, a couple people on our staff, and as a faculty member, we have some really talented graduate students at the university who are working on all these problems, and this is really stuff that generation is going to be facing, and I'm just inspired every day at the optimism and positive outlook they have and the excitement in solving these problems.
Yeah. Well, Rick, I can't say thank you enough. And I want to just thank you all for being here this evening and supporting us and participating and committing to learn and be inspired together. And thank you so much. I hope that I see some of your faces soon. And certainly I look forward to the next speaker series with Bobby Ives as our next guest speaker on October 14th. Thank you, everybody. Rick, thanks, you so much.
Thanks very much, everybody. Really good to see you.
Yeah.
Take
Rick,
care.
We'll talk soon, I hope.
Yeah, definitely, Alicia. Take care. Thanks a lot.
Be well. That was wonderful.
Thanks. It's a lot of fun.